All right, Shane said, my name's Boyd Gregg. I'm an engineer with Energy Systems Group. We are an ESCO. How many of you have heard the term ESCO before? Okay. How many of you have seen a presentation on energy savings performance contracting before? All right, so for most of you, I can promise this is going to be the most riveting presentation you've ever seen on energy savings performance contracting. So we are an ESCO, an energy service company. What we do is perform energy savings performance contracts, and what that is the scope development, design, construction, and performance measurement for capital improvement projects, whereby the savings from these projects pay for the project itself. And that can be through a combination of savings on energy, chemicals, labor, but also new revenue in the form of tipping fees, and I'll talk about that in a little bit. Does that make sense to everybody? So I think the title of this presentation was funding capital cost improvements while stabilizing rates, and that's kind of how we do this. Think of this a little bit less as a financial mechanism, but also as an alternative project delivery mechanism. So everybody's familiar with design build. This is a progressive design build project delivery method. So in your traditional design build, and how many consulting engineers do we have here, if you guys can raise your hands? And then how many from utilities? All right, so we're about half and half. So everybody's familiar with the traditional design build process, or design bid build process, where we go through a preliminary engineering report, develop detailed specs and plans. Those get sent out to bid, and then a contractor will build out their team to provide construction. In an energy savings performance contracting model, the owner still develops an RFP, and that thereby satisfies the competitive bidding requirement through state legislation. And that RFP does not have a project scope defined. So that's a big difference between this and a traditional design bid build model. There is no scope at this point in the project, and there is no price. It's our job to work with the utility to develop this scope and price. We then, after that point in time, after we've defined the project scope, we'll develop a guaranteed maximum price, deliver that to the owner. The owner has not, municipality hasn't had to outlay any capital at this point, and they can decide at that point, after they have their guaranteed maximum price, whether or not they want to move forward with the project. And so then we get, assuming that moves forward, we get the contractor involved. We are a licensed general contractor and also a licensed ESCO, so we perform a bit of a turnkey solution to the municipality in that there's no separate general contractor. We provide that role as well. Move through construction, and then we're responsible for construction, startup, and then performance measurement and verification. So in your traditional design bid build model, the municipal utility hires a consulting engineer to develop these plans and specs. Municipal utility puts those out to bid, and then general contractor delivers the project. The general contractor builds out their team of electrical, mechanical subs, equipment suppliers, and the owner has very little control over who these people can be. That's really up to the general contractor at this point. A little bit, the ESCO model provides the municipal utility a little bit more control in that they can specify, one, the consulting engineer. So there is a role for the consulting engineer in this particular project delivery method, whereas they become a sub to the ESCO in general contractor. But also they have control over who these subcontractors can be, equipment suppliers. Equipment can be sole sourced very easily through this project delivery method. So the owner gains quite a bit more control over who's working on their project or who's not working on their project. So everybody likes to know whether or not this is legal. There is enabling legislation at the state level in all 50 states that allow for energy savings performance contracting. So in South Carolina, these are kind of the general stipulations that repayment has to be made from the utility budget. We have to provide a guarantee. So we as ESCO provide a written contract to the owner that guarantees that the savings that we promised are going to pay for the project. And South Carolina allows up to a 20-year project payback term. This is done a lot in school districts, municipal building facilities. So Energy Systems Group, we have a division devoted to federal facilities, but also to municipal facility work, which does a lot of HVAC building lighting. The ESCO, a little bit of history, this ESCO project delivery method sort of originated out of rural school districts that couldn't afford to replace air conditioning and lighting back in the early 80s. So this was a method by which underfunded school districts could get upgraded lighting and HVAC that would save on their utility bills. We are a pre-qualified federal ESCO. I mentioned we do work at the federal level, so a lot of military bases, we do work there, as well as NASA and VA hospitals. So I talked about construction without a rate increase. A big, I'd say, misnomer in talking about ESCOs is this idea that we get paid back through the savings. We as an ESCO get paid the same way a general contractor gets paid. And what that means is that our job is to find savings that really fund debt service. So a traditional utility budget is made up of some portion of these 5 things: debt service, energy, chemicals, maintenance, labor, a host of other items. But ultimately, through this performance contract, we're going to identify savings that, again, we're guaranteeing through a written contract. We take that savings and we use that to fund the debt service on the project. So the projects can be funded through traditional bonds. We can fund them through lease purchase agreements, hybrid financing. So there are quite a few ways that this can be done. Additionally, we can identify new revenue through tipping fees, and usually there is some excess at the end of the project where there's a net improvement of the municipal utilities bottom line. Quickly, this project development process. So I mentioned that the municipal utility doesn't fund any capital outlays in the form of engineering contracts until this point in time where we have a guaranteed maximum price, and they know what they're going to end up spending. So we go through, skipped ahead there. We go through a pretty extensive project development process whereby we identify what improvements we see that need to be made. We deliver an investment grade audit that can be used in trying to obtain bond financing. At that point, we've got our general contractor on board and our project team, so all additional subs and equipment suppliers. We've delivered a full scope and this guaranteed maximum price that tells us the municipal utility what the project is ultimately going to cost. At that point, they can decide to axe the whole project, or they can pick and choose what bits and pieces of the project want to move forward with, or go ahead and execute the whole thing. So some of the items that come out of this, most of you are familiar with this, but project scope, again, this construction price that we're defining very early in the process. So this is about a somewhere between 30 and 60% design. We've identified what the total cost of the project is going to be. these operational cost savings and new revenue projections, and I'll talk about that in a minute. Again, the savings performance and guarantee. So part of our role as the ESCO is we have to provide this guarantee, and that's required by the state legislation. And so there has to be a plan to measure and verify that we actually did what we said we were going to do. So we've obtained the savings and the new revenue projections that we promised in this contract. If not, the ESCO is responsible for writing a check to the municipal utility for the difference. We have never had to do that before. We've always hit our numbers, but that's a contractual mechanism whereby this guarantee is actually worth something. High strength waste sourcing. So Randy talked a lot about anaerobic digestion. What we've seen with a lot of our customers is that there is excess digestion capacity. We can source and obtain high strength organic waste, feed that to the digesters properly. That results in increased biogas production, but also additional revenue in the form of tipping fees. Talked about, again, we're responsible for construction, commissioning, startup, because we also act as a general contractor through this process. Open book pricing is one thing. So all of our pricing is made transparent to the owner. They know exactly what our overhead and profit is on the project. That's all negotiated prior to execution of this contract moving forward. I talked about the municipal utility being able to select specific subcontractors, but also equipment suppliers. So if they want Ovivo linear motion mixers, that can be specified directly. Andritz belt filter presses. There's no competitive bidding requirement after we've gone through the RFP process. Oftentimes we see that the owner wants to hire their own engineer to provide due diligence on our design and scope. Again, we've hired in most cases, hired a consulting engineer to work with us on our project team, but in many cases the municipal utility elects to hire their own engineer as well to perform design reviews. So we have worked with most of the large consulting engineers in the country in both project partnership relationships, but also in them performing design reviews for us. So why do people use energy savings performance contracting in wastewater specifically? It could be a poor experience with a traditional design bid build process or a design build process. There are quite a few opportunities to optimize maybe operational inefficiencies in wastewater treatment plants right now. And in a lot of cases, municipal utilities are starved for capital budgets. So this is a mechanism whereby they can improve these inefficiencies and maybe generate additional revenue. Sustainability is a big word. We hear a lot in the Northeast where we do a lot of work, but that's important. Stability in future budgets and rates. So again, you don't have to increase rates to fund your debt coverage ratios using this contracting method. Procurement and management. Again, the ability to sole source equipment is appealing to quite a few people. And then on this local economic development, we've seen this in quite a few projects where if we can build out a high strength organic waste receiving station, oftentimes there are quite a few industries that come in. That's appealing to soft drink manufacturers, yogurt manufacturers. There are quite a few food service industries that will locate in the area if they can find a place to dump their waste. Most everybody has seen a version of this graph at some point or another, but this kind of shows where the bulk of the energy is consumed in wastewater treatment. Obviously quite a bit in pumping, aeration, anaerobic digestion. So those are the sort of low-hanging fruits that we really focus on to fund the project. Dewatering is another area where, if we can reduce hauling costs or tipping fees to landfills or reduce land application cost, that can be rolled into that savings bucket as well. Are there any questions so far? Does anybody have any? All right. So some examples of some things that we have done is energy conservation measures that fund these projects. Like blowers and aeration are big. Right now we're seeing a lot of places which have grossly oversized multi-stage centrifugal blowers. That's really low-hanging fruit to go in and put more efficient blower technology in. DO control in places that, or places where you have coarse bubble diffusers, we can put in fine bubble diffusers. There are quite a few operational efficiencies we can gain there. Mixing, recycle pumps. I'll talk a lot more about anaerobic digesters, CHP systems as well. Those are, if I were to say the bulk of our work is really around dewatering, aeration and control, and then in digestion and CHP systems. So looking at electric intensity for a typical wastewater treatment plant, doing BOD removal only, nitrification, a BNR. The typical energy consumption is shown in blue. Best practices are shown in green. You can, if we can get a municipal utility from a typical energy consumption down into that best practices range, that's really the goal here, is try to save as much energy as humanly possible while making the process as efficient as possible. And I apologize for the graph here. I was trying to make it a little bit bigger so folks in the back of the room could see, but it looks like I messed up a little bit. So how many of you have seen a graph or a chart like this? This is called a Sankey diagram, and it shows where the energy in a wastewater treatment plant is going. So you can see the majority of the chemical energy remains in the process, and so if we can make some process improvements, we can reduce biological reactor energy usage and increase gas production. So in a lot of cases, we've been able to make wastewater plants net zero, or where they're actually exporting power to the grid. Randy talked a little bit about the problems with some of the electric utilities, specifically Duke Power. That is a challenge, but I will say that in a lot of cases, if your plant's connected to an investor-owned utility, SCANA being one of those, there are pretty significant advantages right now to trying to sell power back to the grid in the form of biogas. There are some other options in monetizing that gas in the form of RINs. So if you can somehow get that gas into a pipeline and then use it for vehicle fuel, there's a huge economic benefit in doing that right now. So there are quite a few subsidies and programs available through utilities and through the federal government right now where this is really an advantageous thing to do. If you can get the gas and you can get it delivered correctly, there's quite a bit of savings and, again, additional revenue we can help generate there. I want to talk quickly about some of the projects we're currently working on. Frederick Winchester Service Authority, which is in Winchester, Virginia, is one of our larger wastewater projects right now. What we did here was a full aeration project, so replaced all the existing aeration blowers, new DO control system, and then put in a full co-digestion facility. So these are two new primary digesters and a secondary digester, new dewatering facility. And again, this is all funded through a a combination of savings and additional revenue in the form of tipping fees. So there's our digester complex. This was last year. This is all actually in the process of being started up right now. There's the engine generator facility is online now. We're seeding the digesters actually starting next week. Here's the aeration basin. So there was no DO control here. We provided that. New fine bubble diffusers. Replaced their existing, they have 450 horsepower multi-stage centrifugal blowers. We replaced those with 150 horsepower turbo blowers, so quite a bit of a reduction in both connected load but also in operating energy costs there. New gravity belt thickeners for recuperative thickening in the digesters, and a new belt filter press for dewatering. Quite a bit of electrical switch gear involved in trying to parallel with grid power. And then so we've got a 800 kW engine generator, which is really going to make this facility net zero. Receiving station for high strength organic waste and fog. And then this is going to end up taking waste from a soft drink manufacturer as well, which will boost gas production. And they opted to go with a Ostera system as well, so they can try to recover some of that struvite recovery, so they can sell that for an additional source of revenue. This is going to be really hard to read, but this is really, I talked about having a contract with the owner where we're guaranteeing savings, and this is really the guarantee. So this shows exactly how much we promised we were going to save on energy cost. We're also guaranteeing this revenue from the high strength organic waste for a period of 5 to 10 years, depending on who the waste hauler is. Randy also mentioned some of the difficulties in working with organic waste haulers. We take on that contractual relationship as well, where we're providing testing services as well as sourcing strategies and marketing strategies to try to obtain the sort of optimum mix on this high strength organic waste. And then there's some additional savings from avoided capital costs, where those blowers were going to have to be replaced anyway. Since we rolled them into this project, there was some avoided capital and maintenance cost on those as well. So here's where we are construction-wise. This is basically all in the process of startup right now. Hopefully next month I'll be able to report that we're operational here. Digester gas production, we're expecting to kind of ramp up over the course of the next 2 or 3 months. Here you can see our multi-stage centrifugal blowers that were removed and replaced with these high-speed turbo blowers, quite a bit smaller and quite a bit more quiet. I don't know how many of you have worked with these before, but you can stand next to that unit and no earplugs required. Again, no DO control here before. So we did a full diffuser replacement. We were to obtain some operational efficiencies there with replacement membranes, but also providing the most open valve control system for them. It was an old plate and frame press that they were using for dewatering. They were also using an enormous amount of lime, so we can roll that savings on chemical into this project financial model as well. And then here's our new belt filter press right there. And then I mentioned they went with an Ostera system, so they're doing nutrient recovery, and they can sell that fertilizer basically and monetize that as well. We load the digesters a little bit heavier than I would say conventional design would recommend, or than Metcalf and Eddy would say. You can see here we're looking at a volatile solids loading rate of about 130 pounds per day per 1,000 cubic feet, and that's a little bit higher than traditional design. I will say we don't do that blindly. Let me fast forward here a minute. Well, just hold that thought for a second. So that's not just something we're doing to maximize revenue. There is some science behind how we're loading these digesters, and I'll talk about that here in a second. Here's my plug for Ovivo. This is our go-to mixer for anaerobic digestion. This is extremely easy to install, extremely easy to maintain. From a design perspective, it's very easy to show on a set of plans and specs. So this is certainly our preferred method for digester mixing as well. We're doing a project right now in Gary, Indiana. We're going to use 4 Ovivo fixed steel covers, and right now they have 4 existing draft tube mixers. We're going to remove all of those. That's a 50 horsepower mixing system, and we'll end up replacing it with a 7.5 horsepower Ovivo linear motion mixer. So it's quite a bit of a improvement on the energy saving side, but again, from a maintenance and installation standpoint, it's very easy. So co-digestion is another big opportunity we see with municipal utilities. Either there are existing digesters there that are old and haven't been maintained properly in a lot of places, or there could be additional capacity that may be unused. Some of these plants that we see have declining populations. That's not a problem down here, obviously, but in some of the northern states where we work, we're looking at declining populations, and so we can fill that organic deficit with high-strength organic waste. And that could be in the form of fats, oils, and grease. I mentioned dairy whey, which is big in New York right now. Fruits and vegetable waste, so back of the house processed waste. We're looking at a couple of places where cafeteria food scraps can be ground up and fed into a digester. They don't have quite the gas output that grease trap waste or sugar water does, but it's still better than landfilling it. So in that particular, I mentioned that we provide a service to the municipal utility in the form of this managing this high-strength waste. And so we work with organic waste haulers, but also the food processors or waste generators to try to find sort of the optimum balance between obtaining this additional revenue, but also balancing the needs of the existing digestion system. In a high-strength waste co-digestion project, we really need these 8 things to make it economically viable. So that's maybe there needs to be a community driver. We either need existing anaerobic or aerobic digesters, so the tankage needs to be there. Feedstock, so we need some feedstock to put in this digester. It needs to be an accessible location. The Midlands is fairly accessible. You got 3 interstates real close. Heat and energy use, and then this alternative project delivery and financing method as well. Here's how we predict what we're going to get out of this high-strength waste. So you can see here, this just shows the differences between different feedstocks. Manure and municipal solid waste or municipal sludge is pretty low on this graph here. We can get quite a bit of additional digester gas out of some of these different high-strength organic wastes. I mentioned that we don't blindly load these digesters to failure. We don't blindly load them at the expense of the operations of the plant or in order to obtain additional revenue. This is done scientifically. So we work with Virginia Tech to model digester gas production and what feedstocks we can put in the digester to make it run correctly. This was specific to the Frederick Winchester project. So we looked at different, these were the wastes that we had available and what we were going to be loading the digester with. And so we did some testing here where we analyzed quite a few of the parameters inside the pilot scale digesters, and then looked at our gas production as we loaded them to failure, and what kind of represented the optimum feedstock here. Kevin talked a bit about the alkalinity and VFA ratios, so we look at that as well. Again, try to obtain the optimum mixture of these different high-strength organic wastes. Another project we're working on right now is Beckley Sanitary Board. This is in Beckley, West Virginia. So this is an existing 4 5 million gallon a day facility. It's tucked into the side of a mountain. So we're going to be doing a high-strength organic receiving station here, converting some existing tankage into digestion. Same thing, Middletown, New York. This is actually a place where we're loading these up with quite a bit of dairy whey. So Greek yogurt, I don't know how many of you are familiar with Greek yogurt. That's a fairly recent phenomenon, but there's quite a bit of high-strength organic waste that's a byproduct of Greek yogurt. It happens that the majority of Greek yogurt is produced in New York State, and Middletown, New York happens to be right off the interstate highway where these trucks are we're going anyway. So Middletown's going to get about 8 cents a gallon in tipping fees from this dairy whey. So that's going to do two things for them. One, they get this additional tipping fee revenue, but again, it's going to improve their gas production. They're going to be able to sell back. New York State's quite a bit different, but they have some pretty good incentives for generating biogas. So they'll get somewhere around 10 cents a kilowatt hour for selling this power back to the grid. So this project is they have 3 digesters there now. We're converting them all into primary digesters, CHP system, gas storage, high-strength waste storage, and then digestate storage and new dewatering and thickening as well. Rome, New York, again, similar project. A lot of our projects have the same flavor, really trying to develop a CHP system and then using that to fund other projects within the plant. So that could be, again, blowers, DO control. It could be something that may not generate a savings, but if you can bundle all that up into one project, there's sometimes there are quite a few additional capital improvements we can provide. So I'm about on time, right? So here's my quick plug about Energy Systems Group, who we are. So we're based in Evansville, Indiana. I work out of my house in Charleston. I grew up here in Columbia. It's nice to be in air conditioning in Columbia in June. Saw it's supposed to be 100 degrees here on Sunday, so that'll be real nice. We are a subsidiary of Vectren Corporation. Vectren is actually an electric and gas utility focused mostly in southern Indiana. We've done more than $2 billion in energy savings performance contracts since 1994, which is when we were founded. Our first wastewater project was back in 2000, and that's been operating ever since. We do quite a bit of work for the U.S. Department of Energy, Department of Defense, NASA, some other federal agencies as well. We own and operate some dairy digesters in Wisconsin that we use for testing. We also own and operate quite a few landfill gas to energy sites as well. And here's our general footprint. We have offices mostly east of the Mississippi, but we're starting to move a little bit west. Quite a few facilities down in Georgia as well. And then we have people really working remotely all over the country.